Hello everyone and welcome to this channel. My name is Mohib and today I'm going to talk about dynamic data masking and how we can use it to protect our sensitive data in SQL Server. Alright, so dynamic data masking or DDM is a security feature of SQL Server that masks or in other words hides sensitive information before showing it to the end user. And by end user, I mean any database user or any application that queries the database to get a particular result set. The masking is applied at query execution time, which means that the data stored in the disk itself is not masked. So this is different from encryption, where the data is encrypted before it's written to the disk and then decrypted back when it's read into memory. I'll create a separate video about data encryption in SQL Server, but the main purpose of dynamic data masking really is to prevent accidental exposure of information to a non-privileged user. For example, when a call center representative uses his client-side application to pull out customers' information, it's probably a good idea to prevent him from viewing some of the sensitive information like customer's bank account number or the credit card number. This is where dynamic data masking can help. Another example is when there is an in-house database team that have permission to run ad hoc queries. If dynamic data masking is implemented, then the query result would look something like the picture shown here, where the column containing sensitive information is masked and protected from being exposed to any non-privileged user. So this is a really helpful feature, and it was first introduced in SQL Server 2016, and the users of SQL Server 2016 or later can benefit from this feature. Now let's discuss the options we have for implementing dynamic data masking. SQL Server by default gives us 5 types of masking rules. The default rule, email, random, custom, and credit card. Let's first discuss the default rule, and in this case, if the column to be masked is of string data type, which includes varchar and varchar, these type of columns, then the actual values are masked as XXXX, like 4x's. Similarly, for numeric data type like integer or float, for example, the values are masked as zeros. And similarly, the datetime values are masked as January 1st, 1900 and 0 hours. All right, now the next masking rule is email masking rule. And this one is obviously used for columns that store email addresses. And the masking rule says that only the first letter of the actual value and the final .com extension would appear, and the rest of the letters would be masked and replaced by multiple X's as shown here. Then we also have a random masking rule, and this works for numeric data types like integer or float. It assigns a random number from a specified range to each value and hence protects the actual value from being exposed. And we also have a custom masking rule where we can customize how we want to mask the value, and also how much of the actual value we want to hide and how much can be exposed. We will see how this works in the demo in more detail. And the last one is the credit card masking rule that exposes only the last 4 digits of the credit card number. This rule is only available on Azure though, that is on Azure SQL Database, Azure Managed Instances, and Azure Synapse Analytics. Okay, enough talking. Now let's jump to the demo and see everything in action. Alright, so now I'm in my SQL Server Management Studio and let's start the demo. The first thing I'm going to do is to create an employee table with a bunch of columns in it, and straight away I'm going to apply my masking rules to some of the fields in this table. I'm going to mask my email address and the salary fields, and the way to do is to specify the mask with clause against the field, and then specify the function name, which is the masking function name, which in this case I'm telling it to mask it using the email masking function, right? Which will expose the first character of the email address and the .com extension, and it will hide out the rest of the email address. And for salary, I'm using the default masking function since it's a big int column. So the default masking function will convert all the salary values to 0. All right, so let's create this table. And then let's insert some data in it. And I'm going to put this script in the description so that you can access it and follow along. All right, so now I've inserted the data in this table. And now let's see how our employee table looks. So I've got my 19 rows inserted in it. But if you notice, my email address field that I masked is not really masked here, and my salary field is the same. The salary values are the same as I inserted, right? So the reason for this is that I am logged in as sysadmin. So I'm really the administrator of the server, so no masking rule would work for me. I'm the one actually who's creating the masking rule for other users. So I should not expect to see masked values, right? So to see masking in action, I have created a test user, right? And this user only has the data reader permissions. And the way masking work is that anyone with the unmasked permission can view the whole thing. Like masking doesn't work for anyone with the unmasked permission. So either you need to specifically revoke the unmasked permission from a high privilege user in order for masking to work, or you simply grant lower privileged permissions to the users who don't need them, right? So now I want to see how this test user that I created would see this masked data, right? So I am going to execute as user test user, and now I am going to select my employee table, and now I'm seeing this data as masked, which is exactly what my test user would see if he would log into the server using his username and password, right? So this is in this way, even though I am logged in as sysadmin, but I can verify that whether or not my masking rules are working for other users, right? So now let's talk about masking. So my email address, as you can see, is masked now the way I told it, and my salary, all the salary values are 0 for this user. All right, so now I'm going to do a revert, and this will switch my context back to the original sysadmin user. So I'm back again as sysadmin, and now I'm adding a new masking rule. I'm now masking my phone number, and this time I'm using the custom masking rules. And for this, I have to specify, since I already created the table, now I have to alter my table in order to add a new masking rule. And then I would say add masked with, and then I'm going to say the function name. And for custom masking, I would say partial, and this take 3 arguments. The first is prefix, and this is the number of characters that I want to expose in the beginning of the string, and then the number of characters I want to hide, and then this is the suffix, which means that at the end of the string how many character I want to again expose. So with this I'm telling it that for my custom masking, mask my phone number as like expose the first 6 characters and the last 2 characters of the phone number, and then mask the rest of the characters. So I'm going to run this alter employee function, and again check my employee table, and since I'm sysadmin again, so masking won't work for me, and I have to go back to my test user to see masking in action. And here, sure enough, you can see that the first 6 characters of my phone number are exposed, and the middle part is masked, and then the final 2 characters are also exposed. So with custom masking functions, you can customize, like you can create your own masking rule. Now I'm going to revert back to sysadmin, and let's see what else we can do with this. To view all the masked columns in the database, SQL Server gives us a dynamic management view, which is masked underscore columns. And let's see what information it gives us. So we masked 3 columns in our table employee, and this is the list of these 3 columns. And to show you a better view, I have joined this masked columns view with the tables view, so that it also lists the tables these columns belong to, right? So if I run this query now, it gives us a summarized view, kind of like a quick view to see what my columns are that are masked and which table they belong to, and the masking function they are using, right? So this is how you can use the DMVs to check your masked columns. All right, now let's do one thing. Let's grant the unmask permission to my test user and see if masking is available for this user or not, right? So if we grant our user the unmask permission and now run my select star from employee query from this user, now you can see that after getting the unmasked permissions, it is viewing the actual data and masking is no longer available for this user. All right, so if I again revoke unmask from this employee, from this test user, and now if I run this, oh, so it didn't revoke because I have to revert back to sysadmin to actually revoke the permissions, because test user does not have permission to give permissions to anybody, right? So, oh, I need to revert, and now it revoked the unmasked permission from the test user. And now if I run this again as the test user, sure enough, it now sees the masked values. Okay, so we just verified how the unmasked permissions work. Right now I'm going to revert back to my sysadmin, and the final thing is how to drop masking from a column. It's just simple. It's just the regular syntax, alter table syntax to drop something. So I'm going to alter my employee table and alter my column, and I would just say drop masked, and it will drop masking from my phone number, right? So now if I query that DMV, it should no longer list the phone number as the masked column. Okay, so that was it for the demo. All right, so back onto our slides. Let's have a look at some things to keep in mind before implementing data masking. The first one is that with data masking, any user with update permissions can modify the masked columns. So masking does not prevent anybody from updating the values, even if the values are masked. The next thing is that while creating a copy of a table using select into or insert into statements, only the values get copied, and the underlying masking rules from the original table are not copied over to the newly created table. So if the copying user do not have unmasked permissions, then masked values will appear as a result of a select statement, as we saw in the demo with our test user, and the same masked values will be copied into the new table. which is good because moving data from one table to another should not expose it. But on the other hand, if the copying user does have unmasked permissions or higher, then the result set of the select statement will be unmasked, as we saw in the demo with our SA user. So when our Mr. sysadmin will run the select into or insert into statement, then in this case the actual values without any sort of masking will be copied in the new table. Now since our new table do not have any masking definitions on it, then there is a high chance that any other non-privileged user may access it and view the original data. Same is the case when exporting data into a flat file or any other target destination. Whether the exported data will be masked or not all depends on whether the user who is exporting the data has unmasked permissions or not. Alright, so there are two takeaways here. Number one, always follow the principle of least privileges. Anyone can update masked columns, so don't give unnecessary permissions to someone who do not require it, especially when you are implementing something like dynamic data masking and you need to take care of your sensitive data. The second thing is that if you are a high privileged database user, then you have a higher responsibility of protecting the data and you need to be cautious of your actions. You don't want to accidentally expose sensitive information to other users with an action as simple as copying the data into another table or exporting the data into a flat file. Alright, so that concludes this topic of dynamic data masking. I hope you liked this video and learned a good deal about this useful security feature of SQL Server. I wish you good luck for your upcoming projects and I will see you in the next one. Until then, goodbye.